Okay, I think we can start. It's already 16 past 20. So I can see 5 concurrent viewers. Thank you for joining first. But as I said, since this is my first experience in YouTube Live, so I can have problems with it. I need to say that sorry in advance. So in this session, what we are going to do is we are going to be using MATLAB Mobile. First, I'm going to show you how to use MATLAB Mobile and collect sensor data from that. And then we are going to use that sensor data in order to count the steps from a walk, okay? So, but in the meantime, I'm trying to share my MATLAB Mobile screen with you. Just a second, please. Okay. I'm going to share with this application. Okay, I hope you can see that. By the way, I'm just changing my views in between the live session and also the applications that I'm using. By the way, there are some chat messages that maybe I'll miss them. Apologies from now. But please let me know if you can see the MATLAB mobile icon right now. At the moment, I can see that you are able to see that. It will be okay if you can confirm that, please. And we are going to start to use the MATLAB mobile, okay? So I'm going to first click on the MATLAB mobile icon. And if you have installed it already, you can do it with me as well. So once we click on the MATLAB mobile icon and we use our username and password, we can go to the sensors section. By the way, I can see that there is some kind of a lag in between the stream and myself, so I'm trying to wait for that as well. Otherwise, I'm not able to see the MATLAB mobile icon. Okay, so it's opening right now. Okay, no, so for this particular project, or let's say this counting steps project, we need to use the acceleration data, okay? So I'm clicking on the acceleration data, and you can see that we have the X, Y, and Z acceleration information, okay? We have it on our mobile. So when you put your phone on a certain surface, you'll most probably see the X and Y acceleration values as 0 or around 0, okay? And you'll see the Z acceleration at around 9.8 something. Does anybody have any idea why we have that 9.8 value in the Z axis? Actually, it's hard for me to get the responses from you, so I'm going to tell it to you right away. This is because of the gravity, okay? So because of the gravity, we are going to get this value in the z-axis. However, if you change the orientation of your phone, for example, like this, okay, upside down, as if you are using it while you are using it, you are going to see that you see that value in the y-axis, okay? And if you turn your phone this way, you are going to see that value in the x-axis, okay? So that's because of the gravity. So we are going to have that value, 9.8 value for it. Okay, yes, I can see some responses from Jam, Kenan. Okay, good, very good. Actually, you can see those in the Mathworks website as well. So I'm going to show you that. Let me use this one and let me go to Chrome. Okay, so if you check this web link from Mathworks, you can see that we have MATLAB mobile sensor data collection, etc. I suggest that you go through this information. However, what we are going to focus is, actually we know how to set this acceleration, magnetic field, orientation, angular velocity, and position sensors on and off. It's very easy. It's just as if you are using another application. You just click on that slide button and you turn it on or off, okay? So for this one, we are going to use acceleration. In the meantime, you can also use the position. That doesn't hurt, but only acceleration is enough. And if you scroll down to the bottom of this page, you can see the axis, X, Y, and Z axis, okay? So this is the reason we are getting that gravity in the Z axis when you hold your phone on a surface, okay? So be careful with these axes. And there is this explanation. You are going to see that 9.81 is the gravity, so you see that in the z-axis. But if you change the orientation of your phone, that's going to change, okay? So this is something that we need to go through. And the second thing is the other information that I'm going to follow. Most probably, if you have already searched for counting steps, you have come across with this article from Mathworks again. However, when I checked it, there are some things not missing, but that we need to change, okay? So what we are going to do is we are going to skip these sections because these sections are related with getting the sensor data, okay? And we are going to continue up to this level, okay? Plot raw sensor data. Up to this section, I'm going to show you how to get the sensor data. Because, for example, in this article, it's using this Excel log function, which actually didn't work for me. I could not make it work in MATLAB. This is for getting the data and using that in a particular matrix and getting the timestamps of it, but it didn't work for me. So we are going to use a workaround for this, okay? In the meantime, I'm trying to check your chat messages. All right. So what we are going to do is we are going to collect the data and we are going to upload it to MATLAB drive, or you can upload it via sending yourself an email, okay? Or in any other way. And you are going to use that MATLAB data file in our program, okay? This is what I'm going to show you right now. So let me go back to the MATLAB application. Let me show you that. And let me close this Chrome section. Okay. Now that we are in MATLAB, you can see that I'm in MATLAB drive folder, okay? MATLAB cloud folder actually. So whatever you use, okay, in this in your mobile app, okay? So let's assume that we have chosen acceleration and position data and we clicked on start, okay? And after clicking on start, I'm just trying to change the positioning of my phone, okay? I'm trying to give it some acceleration data. The position data will not change because I'm sitting in the same place, okay? So as I'm moving my phone, it's about 22, 23 seconds right now. I'm going to click on stop to stop collecting the data. And then it's going to give it an automatic file name. I'm going to save that. And you can see that in the sensor logs, it's already automatically uploading it, okay? So the sensor log name is ending with 2441, okay? And in our MATLAB drive, I can directly see that one right here, okay? It's already been uploaded, so it's really fast, right? So when I double click on this data file, it's the same thing as loading that file, okay? If you just write down load this data and you enter, when you press enter, you get the data in your workspace. So this is how you get your data into workspace, this section that I'm saying right now. Okay, so since we had opened, so I can close this. So now we are done with MATLAB Mobile. So I'm going to close that. Okay, we don't need it anymore. We can continue with MATLAB. All right, we have acceleration and position, but be careful with this. These are not regular matrix that we are using in MATLAB. Okay, these are timetables, and timetables have different structure. And but when you double click on them, so if I double click on acceleration, for example, it says that 255 times 3. You can see that it says 255 times 3, not 4, because the first column is the timestamp column. Okay, let me check your chat messages if you have any. Okay, okay, sorry for seeing your messages late, because I need to shift to your page. Yes, this will be recorded and you can follow it along after this session. Yes, this is also live broadcast. You're seeing this live. Yeah, there will be a recording. But I suggest that you follow it, because if you have any questions, I'll try to answer them right now. Okay, let me go back to this. Let me go back to MATLAB section. As I said, we have 3 rows which are corresponding to X, Y, and Z acceleration data. Okay, these are meters over square seconds. Okay, just like the unit of acceleration. And we've got these timestamps right here, today's date and today's time. And maybe we can check on the position data as well. We are not going to use it, but you see that again we have a timestamp which gives us the latitude, longitude, and altitude. Also speed, course. I'm really cannot remember which this last column. You can check it from Mathworks website. But I use this data to draw a route on the map. You can check that video as well if you want. So you take your location recording and you put it on a map, so you can see that in one of my videos as well. So let's go back to our acceleration data, which we are going to use that, okay? All right, so I'm back in the MATLAB again. Okay, acceleration data, we have it. I'm sure that if you worked with it, you also have your acceleration data as well. So you can do the same things with me. So what we are going to do is, first, we are going to create a regular matrix out of these acceleration timetable. Okay, actually we would like to, timetables are really powerful tools, but we are going to import that data from the timetable. I'll show you how to do that. Just a second. All right, so first let's write down our MATLAB code. Okay, actually I've already prepared some code, and I'm going to copy and paste it by describing those sections. So what I'm going to do is, actually I have a previous data which was a recording of a walk of mine. I suppose, I hope I'm writing down the correct math file. So I'm going to load that as if I double clicked on it. But first let's clear this workspace. We don't have any figures to close, so we can continue. Okay. Now, okay, I'm switching between windows. This is the first thing that we are going to do. Okay, load it. So I'm going to, from now on, I'm going to just evaluate these selections, and so you are going to see what's happening. Okay, so in this data recording, I had acceleration, angular velocity, orientation, and position. And you can see that we have 6,894 rows in each of them. So when we double click on this, you can see the XYZ acceleration values. And be careful while you are using the sensor log, while you are getting the sensor log from your MATLAB mobile, there is this sample frequency, okay? It's normally set to 10 hertz, so you get 10 samples a second. So you can change it, you can decrease or increase that, but I suggest that you keep it as it is. So and we have the timestamps right here, and it ends at, and where, okay, 6,894. Okay, this is our acceleration data. So what are we going to do? So this Excel log command from the Mathworks website didn't work. Actually, when I even, okay, it doesn't even recognize, or let's say if we say use help Excel log, it says not found. Okay, this is the function that was used in the Mathworks website. I don't know if there was a problem with my installation, but I couldn't get it to work. Also, you can tell me if you tried that and if it worked for you or not. You can write it in chat as well. So let me go back to the MATLAB again. What we would like to do is get a unique time time recording. Okay, so in the timestamp we have the date, the hour, minute, and seconds. But I would like to get something that is unique in a row. Okay, and it will help me plotting this XYZ acceleration data on the x-axis. Okay, at the moment I cannot do that. But what I'm going to do is I'm going to get the hour, minute, and second values from these timestamps, and I'm going to map them or send them to different variables named hour, minute, and second. So let's do that. So let's continue with building our code. Okay. So these are the 3 steps that you have to do. Okay. Now here I'm defining the hour, minute, and second. So maybe I should use this one in order to make you see better. So I'm going to get the hour data from the acceleration timetable. Okay. How am I going to do that? So I'm going to write acceleration, and you can use the tab to complete the function or the variable. And then we are going to put a dot in order to go through its properties. Okay, acceleration has properties, and one of them is the timestamp. I'm choosing the timestamp, and in the timestamp I can choose, when you press on the tab, day, format, hour, minute, etc. I'm going to choose hour. Okay, so this line is going to give me the hour information from the acceleration timestamp, and it's going to send it to the HR. It's going to be actually a column matrix, okay, column vector, and we are going to see that. I'm going to do the same for the minute and second. So let's evaluate these selections and see what happens. Okay, now I have hour, minute, and second. You can see that they are column vectors. When I click on hour, I'm going to get, okay, this was taken in 15 in the afternoon, okay, 3 p.m. And it's how many lines did we have? Probably it's going to be, okay, it reaches out to 16 as well, 4 o'clock in the PM. And if we look at the minutes, it's 58, it's going to increase. Okay, we are going to have the minute data, and we have the second data. Okay, now I'm going to merge all of these data in order to have a unique time value for myself. And it's going to be very easy, because an hour is consisted of 300 and 600 seconds, a minute 60 seconds, and I'm going to then add it to the seconds. Okay, so what I'm going to say is I'm going to say a unique second, okay, for example, is going to be hour times 3600 plus this and that. You can follow it along in the stream. Okay, in the meantime I'm checking your chat messages, okay, if you have any. Okay, all right, so let's evaluate this selection as well to get the unique second in variable. Okay, we have the unique second. Let's check what that is. Okay, so these are single values, okay, corresponding to the second. Okay, I'm showing the whole value, hour, minute, and second value. I'm adding them together, and this is the total seconds. Okay, so I'm going to have an axis for myself. Okay, seconds axis. So I will be able to map all of those x, y, and z variables in that axis. Okay. All right, since we have our axis, now we can continue even starting from the Mathworks website. So let me show that to you once again. Okay, now I'm going to close this one. Okay, let's see where we are. Okay, now actually we can plot. We have the t. Okay, so t was okay the relative time. Okay, in this function. Now we have the t, and what did we call that? Let me check. We call that unique underscore sec. Okay, unique underscore sec, and that will be our t. Okay. And we will be able to plot and we will be able to continue from now on. Okay, from now on, if you use the correct variables that you created, you can continue with the code from Mathworks site, and that's what I'm going to do right now by describing that to you. Now that we can continue with plotting this acceleration data, let's do that. Let me check. Sorry, let me check from the streaming. Where are we? Okay, I'm going to use MATLAB. I'm going to send this Chrome. Okay. All right. Now we are continuing editing our file. We have our unique second. Now, okay, well, there is something else that I'm going to do. I'm going to create a new final matrix that is going to be consisted of this unique seconds. Okay. The acceleration x, acceleration y, and acceleration z. So I will have a matrix which has 6,894 rows and 4 columns. Okay, first column is going to be my time, and the remaining 3 columns will be my acceleration data x, y, z. So let's create this. By the way, if you don't know how to use these square brackets, that's for concatenating your columns. Okay, so that concatenates them and creates a new new matrix. Let's evaluate this. Now we have this final matrix. You can see that we have our time here, x, y, z. So now we can work with this matrix very comfortably. If you have any questions, let me check them. In the meantime, can we just make, Jam says, can't we just make t is equal to acceleration dot timestamp? Actually, I didn't try that, Jam. You can try it for yourself, but actually it makes, I feel more comfortable with using such a basic matrix, okay? You can try to do that. Maybe that's possible. That will probably be possible, okay? Sorry, but you will not get a unique ID, okay? So I'm not sure when you use that timestamp as a whole, you will probably get a problem with your axis. But try that. If you can use it, why not using it? But in my opinion, this is much more simpler. Okay, so I'm going to go back. Okay, we created our final matrix. Now I'm going to use the code from the Mathworks site. I'm going to change it according to my variables. Okay, I've created this final matrix. I'm going to plot the acceleration data, and this is my t, right? This is my time, the first column. I'm going to give the names x, y, z as legend, x label, y label. These are all from Mathworks site. Let's evaluate these selections. It's going to plot it, but I will have to share that plot with you. Okay, I'm going to show that to you. I need to do that in my streaming tool. Just give me a second. I'll define that as figure, I'll edit. Okay, good. Okay, now you can see it, I guess. Yeah, okay, you can see it. Now we have plotted the acceleration data, x, y, z. You can see that since there are lots of information, it's hard to analyze it. Okay, but we can zoom on it in a section. Let me check. Okay, this is the XYZ acceleration data. We plotted it. All right, so I'm going to, okay, all right, I'll get rid of that. Let me continue with MATLAB. Now that we have our data, let's continue writing our code. Okay, now what we are going to do is, you can follow along with the Mathworks site. We are going to get the magnitude of our acceleration vectors. Okay, so we have an acceleration made up of three axes, okay, x, y, and z. But we don't know how our phone is being held while walking. If you can hold it like this, you can hold it in a different way. However, you need to get this magnitude of the vectors, all x, y, z acceleration vectors, so that you get a certain magnitude. Okay, it's not depending on the axis. So how are we going to do that? You can follow along with the Mathworks website. Please, if you have it open, you can follow that from there, that section. And now here I define the x, y, and z as the second, third, and fourth columns, which are x, y, z of the acceleration data. Okay, let me check if you have any questions. No, good. All right, so we are going to get our x, y, z. Then this is the magnitude of our vector. Okay, so it's the sums, it's the squares added together. Okay, these are the squares added together, and we are going to get the square root of it. So this comma 2 is, by the way, these are dot product or dot power. Let me check what that was. I had already checked that. That's element-wise power. Okay, so that's actually getting each element in that column and getting its square. Okay, then we are adding them together, and then we are adding these together. Let me check. You can see it. Okay, yes, you can see it. And then we squeeze them in a column vector again. So this magnitude is going to be a column vector, which is consisted of the square root of sums of the squares of x, y, z. So we get the vector's magnitude, okay, or length, you can say. Let's use this selection. Okay, now we have our mag as well. Okay, let's look at that. So this is square root of x squared plus y squared and z squared. Okay, so we don't have the directions anymore, but we have a certain magnitude. Okay, magnitude of acceleration. Let me check if you have any questions. No. Let me know, by the way, if you have any questions. Let's continue with building our code. And we are going to plot this magnitude with our timeline, okay? And let me use my comments. I'm going to paste them right here. Please follow along. I'm going to say, in order to not to work with this final matrix, I'm going to say that this is my T, is the first column of my final matrix. Then I'm going to create another figure by saying figure, and I'm going to plot the magnitude. Okay, let's evaluate these selections. Okay, let me check if you can see it, because I need to define it as another figure, I guess. No, you don't see that. Let me check. No, not this figure. Let me delete, remove this one. Okay, I'm going to add this figure so that you see figure 2, let's say. And I want okay, this one. All right, now I guess you can see it. Let me check. And not yet. Okay, that's because of the delay, I guess. In any case, let me check that. Okay, you can see that one. Okay, perfect. Now this figure is the magnitude, okay, the value that we got by the square root of the sum of the squares. But the problem here is, you can follow along from the Mathworks site as well. It's not zero mean, meaning that it has already a bias, and that is the gravity. Okay, you can see that it's fluctuating around 10 meters over square second. Okay, so we need to get rid of this. As I said, this is again from the Mathworks site. You can follow along. I'm going to continue with that. Oh, okay, where's MATLAB? All right. What we are going to do is we are going to remove the mean value or from mag, okay, from our magnitude. And this is how we do that. We get the mean value of mean by saying mean magnitude, and we subtract it from mag. And this is mag NOG, means no gravity, okay. I tried to understand what that meant. I believe that that's no gravity, okay. So without gravity, we have our value is going to be mag and no gravity. And now let's plot that. So we will see that we got rid of the mean value. Let me share this one again with you. I'm going to say plus window capture figure 3. Okay, figure 3, mean subtracted. All right, this one. And now you can see that. Let me check if you can see that. I guess so. Okay, there's a delay, so I will not wait for that. So this is our mean subtracted. You can see that it's fluctuating, this time around 0. Okay, so we got rid of the gravity, and now we have our ups and downs of the acceleration. So what we are going to do is actually, as advised on Mathworks site, is we are going to find those peaks. Okay, so why find those peaks? Because during walking, or let's say running, so those instant moves that you make, not depending on your the orientation of your phone, will be your steps. Okay, your instant big accelerations. Okay, so you move here and there, and you need to find the peaks for this one. Okay, so let's continue how we can find those peaks. Let's go back to MATLAB. I'm going to get rid of this figure now, figure 3, so that you see MATLAB clearly. All right. Now we are going to use, actually this is from the signal processing toolbox. You can check. So you need to have a signal processing toolbox, as said in the Mathworks site. Probably you have it. So this section is what we are going to do. We are going to get, first we are going to get the standard deviation of this. You should all know what standard deviation is. You can check it even from Wikipedia. Now with this function, which is a very useful, handy function, find peaks, it speaks for itself. It's going to find the peaks of that data, okay, which is mag no gravity for us. And we are defining the minimum peak height as the standard deviation. This can change, okay. You can increase that value, decrease that value. For example, if you are walking in some kind of, if you are climbing a hill, maybe your maybe your peaks will be lower, okay, and or maybe that can change on the terrain that you are using, that you are walking, running. So, but for this one, we are going to use this standard deviation as minimum peak height, right, as shown right here, and this is going to be our number of steps. Okay, let's check what, actually I didn't check this command first. earlier. Let me check with you. Let's say help numl. Okay, numl. Okay, what it does is number of elements in an array or subsequent array expression returns the number of elements and in a. So we are going to find the peaks with this find peaks function. Okay, and we are going to say set it here, and then we are going to say that we are going to get the number of it. It's that as easy like that. Okay, let me check any questions. No questions. Okay, good. Okay, let's run this section with you. Evaluate selection. Okay, great. Now we have reached our conclusion. Okay, we found the number of peaks in no-gravity, and that's 634. Okay, so that got it. So we can even draw that one. I'm going to show you that with this code. It's again from Mathworks website. We are going to run this in order to see the peaks. Okay, evaluate selection. Now I have, where is my figure? Okay, I'll share that figure with you once again from the streaming tool. This was our figure 3. Okay, good. You can see that. Maybe I can increase its size. All right. So these red triangles are the found peaks. Okay. Those are the peaks that we were looking for, and for us, it's corresponding to the steps. Okay, that acceleration that we are doing for that. Okay, let me have. And you also got your value with from MATLAB as well. You got it as well. Did we have that? It was number of steps. You have it in your workspace, and that's 634. Okay, you can say that. With this data, we identified 634 steps. Okay, let me again maybe share this one with you. Where was that? Okay. Let me change its positioning. All right. So if you followed along till now, you should have understood how we did that, how we modified the code from Mathworks site, how we built that, let's say, from the signal processing toolbox, we used the find peaks command and all of the previous commands as well. We created a new matrix, which was easier for us to work with. Okay, any questions, anything that I missed? Because as I said, I'm a rookie in this live session in YouTube. I had many live sessions with my students, but this is my first time. So I don't know if I skipped showing you a part of it. And we still have 4 viewers. If you have any questions, I can answer them. Jam says we must log new data for every time in this method. Sure, Jam. If you are asking about the live data usage, actually, that was, as I understand, that was possible in some previous versions of MATLAB. Okay, I tried to do that as well. So I tried to use this sensor data from the phone instantaneously, but I couldn't make it. So if you look it up in the internet, you can see similar results as well. So you have to create a new log, you have to get the data, you have to save it, upload to Mathworks Cloud, and use it in your MATLAB desktop or MATLAB Online. By the way, you know that you can use MATLAB from your web browser as well. It's very cool, actually. You can directly log in with your account. I'm not sure. I don't think if it's full, it has the full features, but you can use it from a browser, and which is very cool, in my opinion. I hope that was an answer for you, Jem. There are also 5 people watching, so if you have any questions, please let me know. I don't want to take too much of your time. It's been already 47 minutes since I started the stream. I hope the stream quality was good. I don't know. You can send me your feedbacks, the voice or the video. I don't know how it went since I have no idea how you saw it. And as I said, this was my first trial, so you can expect some errors in the meantime. I guess it's possible with mobile dev. I'm not sure, really not sure. Is that a different application or okay, is that a function that you are calling from MATLAB desktop? Please let us know later on in the comments if you could make it. Actually, I was not able to succeed doing that online, getting that data instantaneously. Any other questions? I don't know if Recep is still watching. I guess you had some kind of a homework like this, right? I hope this was useful for you. I mean, if you could not follow the session, you can rewatch it. I can also upload the whole code in GitHub. Later on, I can upload it to GitHub as well. So did it worth it? I mean, is it a big percentage of your grade? That homework that you are mentioning? Any other questions? Kenan, we have actually 2. Kenan joined the session. Thank you. I also thank you for joining. This was, as I said, this was my first session with you, and you were my first guests. And I suggest that you check out the channel as well. What I'm trying to do is I'm trying to make some videos about MATLAB for microcontrollers and also for FPGA in the last couple of weeks actually. And you can find it in my homepage as well. I'm also an electronics and telecommunications engineer, and I'm trying to share this kind of stuff. I'm also having sessions with. I'm also trying to use these sessions for my own students as well. But this was a new experience for me in YouTube. Okay, so if you don't have any other questions, I can end this stream. I really thank you so much for joining, and I hope it was helpful for you. If you don't have any questions, I'm going to stop the stream. Any questions, any suggestions? No suggestions? Okay, then I guess I can stop this session. And if you have any further questions, I guess you can use the comments for this one as well, because it can be replayed on the channel. Thank you for joining. Thank you, Jem. Thank you all. And maybe we can see you again in another live session, okay? Thank you and see you later. Bye. Thank you. Thank you, Enver. I'm closing the stream.